In this video, we're going to go over the fifth example of graphing rational functions, completely graphing calculator free, but we just check it with our graphing calculator when we are done. So let's see what we have. We have a quadratic over linear. They said graph the rational function, start by drawing all asymptotes. So they are all the same type of problem, but you know, just a more example I thought will be helpful. So here, let me go ahead and start by finding the vertical asymptote. Uh-oh, I wrote too big. Vertical asymptote, okay. That happens when the denominator is equal to 0, right? But we need to make sure that that factor doesn't get canceled out with the numerator. Check and see if the numerator can be factored. Only pair that will multiply to be 1 is 1 times 1, but they will not add up to -5, so we do not have to worry about a whole here. There's only a vertical asymptote at when this is true, when the denominator is 0. If I add 3 to both sides, we have a vertical asymptote at x equals 3. So go ahead and graph that with the dotted line at x equals 3. And then now we need to find the horizontal asymptote. Horizontal. And you know how we do this one by cases. Okay, so what's the function? Let me go ahead and write the function down here. F of 3 is x squared minus 5x plus 1 over x minus 3. Okay, I'm looking at the degree of the numerator. Degree of the numerator is 2. The degree of the denominator is 1. So what case is this? This is when degree of the numerator is bigger than the degree of the denominator, and exactly by 1. So guess what kind of asymptote we're going to have? But one thing for sure is that we're not going to have horizontal asymptote. And it's because the top will get bigger faster and faster, really, and the function will just go positive infinity. Okay, so, but I just noticed that because n is greater than m by exactly 1, what kind of asymptote do we have? F has a slant asymptote, okay? And in the previous example, guys, I think example 3 or so, I used long division to find the slant asymptote. I will do the synthetic division to find the slant asymptote this time, okay? So slant asymptote. Work. I am dividing the numerator, x squared minus 5x plus 1, by the denominator of x minus 3. Uh-oh, my little daughter's moving, so my pen's... Okay, so if I set up the synthetic division, I will have 3 in the little box. The coefficients are 1, -5, and 1. Let's go find that quotient. So bring down the 1. 3 times 1 is 3. Add, I will get -2. 3 times -2 is -6. Add, and I get the useless remainder of -5. We don't care about the remainder. So the slant asymptote is this. Slant asymptote is at y equals 1x minus 2. And if you're wondering where did you get that from, we just need to read the quotient. 1x minus 2. So we're going to go ahead and graph that, okay? So review of graphing a linear function. Plot -2 on the Which axis? Y-axis. That is your mx plus b. So you're going to plot that -2 on the y-axis. And from that point, we will go up 1 over 1 to the right. That's how you will graph that slant asymptote. So let me do what I just said. So down here, I will plot a down 2. And I will go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You can keep on going, but that's probably enough for me to see a pattern. So I'll go ahead and draw a dotted line, a slant asymptote. Oh, it's extremely difficult for me to see. So I'm going to go ahead and plot all these dots. Because I was going to go to the wrong thing. All right, this is perfect on the right end. So dot, 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 dot. Okay, this is perfect. So I know my graphs will be in 4 of these regions. So 2 of them will have a graph and 2 of them will not. So let's see what I need to do now. I need to pick 2 points to the right and to the left of my vertical asymptote. So how about I set up my x and y table, x and y. Okay, and let's pick some values to the right side of 3. Right side of 3 is 4 and 5. I can plug in 4 and 5 in here. There is no guarantee these will come out pretty. If they're ugly, I guess we're going to have to plot those. But what's the function? I forgot. The function is x squared minus 5x plus 1 over x minus 3. So we need to plug in 4 into this function. So y will be 4 squared minus 5 times 4 plus 1 divided by 4 minus 3. Because the denominator is going to be 1, we know it's going to be a nice number, don't you think? I hope it's not like super big number that we can actually plot. You guys plug this in. I plugged it in and it got me -3. That's a beautiful number. So I will plot a point at 4, -3. Next one, 4, oh, not 4, but let's this time plug in 5. 5 squared minus 5 times 5 plus 1 all over 5 minus 3. And I really just typed this into my scientific calculator, which is like my best friend now, don't you think, guys? We need this little thing. Oh, it's okay. I got a half, which is not bad at all. We're going to go ahead and plot these 2 points. Half is 0.5. In between 0 and 1, I will plot that point. So first, 4 to the right, down 3. 4, -3. 4 to the right, down 3. So I have my first point right here. What's the next point? I forgot. The next point is at 5.5. So 5 to the right, go up half. That is it, that is it. Kind of not sure what it will look like, but I know as it's going up, this is going to follow that blue slant asymptote, and it's going to come down and try to get really, really close to that vertical asymptote, but it's not going to be able to cross it. So we got this so far. Let me zoom out. So I need to have another piece of the graph to the left of the red line. So let's pick 2 more points that are to the left of +3. So guess what? What are some numbers smaller than 3? I can do 2 and 1. I'll plug in 2 and 1 this time, okay? I need another page right here. I'm going to add a page. I'm going to plug in 2 and 1. 2 and 1. If I plug in 2, I will get 2 squared minus 5 times 2 plus 1 over 2 minus 3. All right, plug that in, you guys. Let us compare what we get. I got 5. Hello, that's a super nice point to plot. Let's plot 2, 5. But let's get this one too. 1 squared minus 5 times 1 plus 1. And if you're wondering, how are you picking these x values to plug in? I'm just randomly picking 2 numbers to the right and 2 numbers to the left of my vertical asymptote. okay? And that's what they wanted. So these are just completely random. And I got 3/2. So I will plot a point at 1, 3/2, which is 1.5. So let me plot those two now. 2 to the right, up 5. 2 to the right, up 5. So a point right here. And what's the next one? 1 to the right, 1.5. 1 to the right, 1.5. So I have 2 dots right there. And I know this graph will try to go to the right, but it will never be able to touch or cross that vertical asymptote. It's going to come down and touch this point, and it's going to keep on going down, following along that blue slant asymptote. So this is my graph that we did by hand. It's time for us to check this by a graphing calculator, okay? So let me go ahead and hide my iPad screen, and I'm over here. That was the previous function, right? Let's plug in the function. This one is, I need to make this into a function, a fraction first. How do I do that? Maybe I can just type in x squared minus 5x plus 1 in a parenthesis, and then I'll divide that by x minus 3, okay? I can zoom out. It looks like our graph, but we will be more sure if we actually graph our asymptotes. Whoopsie, the first the vertical asymptote is at x equals positive 3, and it looks like that's good. And the second horizontal asymptote, the horizontal didn't exist, but we had a slant asymptote at 1x minus 2. And if I go ahead and use a dotted line, and oh my gosh, isn't that beautiful, you guys? You see the graph is bounded by these asymptotes, these dotted lines, and it's following. This is exactly what we had by hand, okay? Let me go ahead and show you what we had. Ta-da! See, it's close enough, right? So that's probably good for this example. We really have only one example left, the one that has hole in it. So come back and watch the last one for me, okay?